A key to assessing performance of a water treatment plant is to collect and evaluate specific data. Since there may be considerable variation in that info, it is helpful to look for and interpret trends and averages. The arithmetic mean is the most commonly used measurement of average value and is calculated by taking the total of all terms and dividing by the number of terms. In the case of raw water turbidity, a reading taken each day provides the operator with the average daily turbidity as shown. The total turbidity readings of 48.4 divided by 7 days provides an average of 6.91 turbidity units. Next, we'll take a look at percentages, which is simply a term used to indicate a number per 100. There is a direct relationship between percents, fractions, and decimals. They are just different ways of expressing the same mathematical proportions as shown here. A fraction is the key to calculating percent. The fraction is divided out, resulting in a decimal number that is then multiplied by 100 to be expressed as a percent. Here's a sample problem of working with percentages. A tank is filled with water to 55% of its capacity. If the capacity of the tank is 2,000 gallons, how many gallons of water are in the tank? First, write down the equation for percent and designate the unknown value, which in this case is the part or numerator. You can then solve the equation and determine that the answer is 1,100 gallons. Linear measurements are used in water operators' calculations. This distance, or length along a line, can be expressed in inches, feet, yards, or metrically in centimeters, meters, and kilometers. Linear measurements are one-dimensional. The perimeter of a shape with straight lines is determined by adding the length of each side. To accurately measure a circular shape, such as a circular water tank, determine the diameter, which is the distance through the center of the circle. That length times the ratio, pi, which has a value of 3.14, is equal to the circle's perimeter. So the formula is circumference equals 3.14 times the diameter. Area measurements, as opposed to linear measurements, define the size of the surface of an object. Area measurements are two-dimensional. For area measurements in water treatment plant calculations, the three most utilized shapes are rectangles, triangles, and circles, or a combination of these shapes. Here's a quick review of the surface area formulas we use for each particular one. Rectangle area equals length times width. Triangle area equals base times height divided by 2. Circle area equals 0.785 times diameter squared, or pi 3.14 times the radius squared. Since the diameter rather than the radius is generally given for circular tanks and basins, the formula using diameter is preferred for water treatment plants. That formula is expressed as area equals 0.785 times diameter squared. A volume measurement defines the amount of space that an object occupies. Volume measurements are three-dimensional. The units commonly used in volume measurements are cubic inches, cubic feet, cubic meters, liters, gallons, and acre feet. The calculations of surface area and volume are closely related. For example, to calculate the surface area, you multiply two of the dimensions, length and width. To calculate volume, a third dimension, the depth, is used. Volume equals surface area times the third dimension. It should be noted that the area of surface used in the volume calculation is the representative area, or the side that gives the object its basic shape. In treatment plants, representative surface areas are most often rectangles, triangles, circles, or a combination of these. The volume formulas are closely associated with the area formulas we just looked at. For rectangular tanks, volume equals the area of the rectangle, or length times width times the third dimension. For a trough, volume equals the area of the triangle, which is base times height divided by 2 times the third dimension. In the case of a cylinder, volume equals 0.785 times the diameter squared times the third dimension, or height. the volume of a cone equals 1/3 times the volume of a cylinder. Sphere volume equals pi divided by 6 times the diameter cubed. Use the formulas just mentioned to answer the following questions, and then resume the video once you have checked your answers. What is the volume of water in the circular tank pictured here that is 10 feet in diameter and 12 feet deep? This next problem involves a representative area that is a combination of shapes, so you'll need to calculate the area for both the rectangle and the bottom of the storage area, which is a half circle. What's the total volume of the tank? Conversions are an integral part of calculating water plant formulas. To convert, you must know the number that relates the two units and whether to multiply or divide by that number. For example, in converting from feet to inches, you must know that in 1 foot there are 12 inches, and you need to know whether to multiply or divide the number of feet by 12. Those are numbers we're all familiar with, but sometimes the units are unfamiliar to us. The quickest way to convert those units is to use a conversion table like this one and follow the instructions on the table headings. The conversion chart provides the necessary information to convert U.S. customary units such as converting cubic feet to gallons to pounds, flow conversions, linear measurement conversions, area measurement conversions, and volume measurement conversions. There are also concentration conversions, such as milligrams per liter to grains per gallon, milligrams per liter to parts per million, metric system conversions, cross-system conversions, such as gallons to liters, and temperature conversions. If a conversion chart isn't available, another method used to determine whether multiplication or division is required for a particular conversion is called the box method, and is based on the relative sizes of different boxes. Because multiplication is usually associated with an increase in size, moving from a smaller box to a larger box corresponds to using multiplication in the conversion. Since division is associated with a decrease in size, moving from a larger box to a smaller box corresponds to using division in the conversion. To use the box method, place the unit that corresponds to 1 in the smaller box and the remaining units in the larger box. The conversion number is placed on the line between the two boxes. Determine whether it's appropriate to multiply or divide based on the size of the boxes. Moving from a smaller box to a large suggests multiplication.